Hi, and welcome to the Data Science Salon Podcast. If you're returning, welcome back, and thank you for being here again. And if you're listening for the first time, we're glad to have you here. Thank you for choosing the DSS podcast. We know there are many choices out there. I'm Anna Annison, your host and the founder of Formulated By, the home of Data Science Salon, which is soon going to be AI Loves Data. And joining us today is Dushyanth Sekhar, who goes by Dush, so I'm going to call him that, a leading expert in AI, machine learning, and data-driven innovation. Dush has an impressive track record in designing and deploying scalable AI systems, transforming complex data sets into actionable insights, and applying cutting-edge machine learning techniques to real-world business challenges. With deep experience across enterprise environments, Dash brings a unique perspective on bridging technology, business impact, and responsible AI practices. Today, we'll dive into his journey, the most exciting developments in machine learning and AI, and practical lessons for building systems that truly deliver value. It's such a pleasure to have you here with us today, Dash.
Thank you for having me, Anna. Appreciate it.
Well, welcome. And can you start by telling us a little bit about your journey into AI and data science and what initially drew you to this exciting field?
I was always interested in math, the statistics, and also as a kid, so that kind of helped the cause. But I can't think of like one event which pivoted me towards it. But if I think back now, I used to play a lot of chess as a kid and was a big fan of Gary Kasparov. And when the machine beat him, the Deep Blue, in I think it was 93 or 94, I was pretty upset. And now, if I look back at it, I think me getting into this space had something to do with it, probably.
Well, that's cool. That's a cool story. And what do you see as the most exciting or kind of transformative trends in machine learning and AI right now, especially this year?
Oh, that's a tricky question, but I think I could give you some general sense. It's kind of very difficult to predict nowadays. If I say something now, 6 months later, then most likely I'll be wrong. But I think on a more strategic level, I think we're looking like there's a fundamental shift from just generative systems, which are like create a text or create an image, to more agentic systems, right, which are executing and taking actions. I think you might see more traction in that space. So we were in that wow phase of the chatbots, but now it's more of a work phase, right, where AI systems function as reliable, autonomous teammates. So I think that's one shift I see, which is already happening. I think that's going to gain some traction. Secondly, I think there is the reasoning side of it, the thinking AI, if we can call it that. That most models now they're kind of think before they speak. So you could see the reasoning, and this could be critical to solve problems in math, coding, and science, right? Because those are more reasoning kind of problems. The third trend I see is that I mean AI enters the physical world, like embodied AI. So the kind of the vacuum between the physical and the non-physical world could kind of converge a bit, and the AI could fill that gap. Very excited about quantum computing. I don't see maybe 2026 we may not see massive uptick in adoption, but I think the technology is moving really really fast. So I think that there will be more inroads there. And lastly, I think a lot of people don't talk about the chip side of this. I think there are some interesting options now in terms of inference. Whether you want to use Grok is a big player. You saw some deal they had with Nvidia now. So I think that's a kind of a more not a space which makes a lot of headlines, but chips could get cheaper, and inference could get cheaper as well as a result of that. So
So
broadly, those are some trends I see.
cool. Well, maybe we could go back and talk a little bit about quantum computing for people that don't really know. Like, how would that change the industry if that actually something like that worked?
I think at a very high level, I mean, if people are familiar with the classic P versus NP kind of problems in computer science, so there are some problems which classical computers cannot solve, right? Like, the traveling salesman problem or things like that. With quantum computers, you can open up a door where some of those problems could be solved in polynomial time. I mean, we are still far away, we don't know, but it's potentially possible. Effectively, quantum computers can maintain intermediary states, what we call qubits, unlike binary states of 0 to 1. So that kind of helps it to process things which, traditionally classical computers cannot. The implications are a little difficult to kind of fully ascertain right now, but definitely on the cryptography side, there are significant implications, right? A lot of the protocols today for infosec are based on the assumptions that computers cannot break through in polynomial time. But if that changes, then a lot of the protocols could change in that side. So there could be a significant implication there. So we are already talking about things like zero knowledge proof and things like that. So, and plus, okay, a lot of the problems which are require high levels of processing could become more mainstream and solvable. Unlikely this will happen in 2026, but I think a lot of the foundations which have been built could gain much more traction in 2026.
Cool.
But
No, that's
I
a
could be
great
wrong.
answer.
I don't know.
That's a good answer, though. No, that's a great answer. Well, now let's move into a different kind of topic. Can you share an example or two of a particularly challenging AI or machine learning project that you've led and how you navigated the technical and organizational hurdles?
Oh, okay. I think the first one was always the trickiest one because it was uncharted territory. I go probably rewind the clock 6, 8 years back. So these were more supervised systems. The first one we introduced, it was tricky, right? Like it was foundationally changing the way we curate data. So we didn't have all the information. We made some mistakes as always, learned from it. But I think the change management is also hard because humans tend to overestimate risk and underestimate opportunity, generally speaking. And it's difficult to unlearn things, right? You're used to doing things in a certain way. So the first supervised system we built for one of our collection processes, where we kind of let the machine have the first pass and then the human come in and curate it, which was a lot of change management involved there. So probably that one was tricky. We have had more computationally complex problems, but I think overall I'll probably that was a challenge. I think the way to overcome those things are show value. I think value speaks louder than opinion. So once the business sees the value with these systems, we became faster to market. In some cases, we were 5x faster to market. The number of customer errors significantly dropped. So once those value realization happened, I think the path was much easier.
Awesome. No, that's a great story. Thank you so much for sharing. And what are some of just like more common hurdles that companies and industry encounter when they're deploying AI at scale? And like, what are some of strategies that you use to navigate those?
I think one of the primary challenges, you should be very clear is what is your customer value proposition, right? That how is AI kind of adding more value to the customer? So I think you have to start with that first, right? If you don't, then you will run into some hurdles because you can't just be doing AI for the sake of AI, right? So that's kind of foundational because the core value proposition to the customer has to be clear depending on what business you're doing. I think I was chatting with somebody of last year and they gave me this great example, right? They say that they were telling me that let's say if you're making hamburgers, so you have a hamburger stall somewhere in downtown New York, And one day you introduce an AI chef, right? And you say, okay, now my burgers are going to be made by an AI chef. People will come, right, once because they're excited to see how an AI chef makes burgers. But eventually, the continuity of the business and the value to the customer is taste, hygiene, price. So those dimensions don't change just because you start using AI. The burger still has to taste good, it has to be hygienic, things like that. So I think that's one. Secondly, when you're looking at AI to introduce into workflows which are human driven, and then you want AI to kind of be a supplemental resource, I think you have to kind of optimize the process before you kind of induce any AI components, right? Because the way processes are set up for humans, they might not be the best way for a human and AI to work together. So some lean and those kind of stuff have to be thought about. Because if the process is not optimal, then you might not get the true benefit of the AI, right? And lastly, I think you will fail a few times, so that has to be inbuilt into the ecosystem. uh, these are not linear problems, so people, sometimes you think, oh, when will a model achieve a certain accuracy? You don't know, nobody can answer those kind of questions. So you'll have to factor in some failure, but at a higher level, if you'll have to make a lot of bets. Your hit rate might be low, but the bets which pay off will have a very high payoff. I think that's a fundamentally different way of allocating capital also to AI projects.
Oh, that's a great answer. Thank you. And can you walk us through maybe an example of a complex machine learning pipeline that you've built? Maybe something that has involves multimodal data and real time and inference or production level scaling? If you're enjoying listening to my conversation with Dush, you'll have a chance to see him speak at our upcoming event at DSS ATX on February 18th, taking place at Oracle's beautiful headquarters in Austin. Use code DSS Podcast ATX to get 25% off your registration.
Yeah, so today, if you look at within S&P, we're a part of the enterprise data organization. About 2.5 to 3,000 people use fairly sophisticated AI systems to curate a lot of data, right? So we look at AI as being a part of our entire fabric on how we source, curate, collect, and normalize data. So we don't see this as some separate thing. So a lot of the pipelines we are built are very integrated into our workflows, right? Where the AI is just one piece of the puzzle. Complexity is like, I think the complexity now, the way we are looking at it is we are also looking at multimodal approaches, right? So when I say not multimodal but more multimodal, where we could say that, okay, I rather than just optimizing one model, I might use a bouquet of models which are mutually exclusive and perform the same task, and then some consensus model is built on top, what we call an LLM judge sometimes, and they look at outputs from each model independently and then kind of form a consensus and say, okay, this is correct. So that gives you second layer of defense, especially when the failure rate, the tolerance to failure is low. So if you want to really minimize your loss functions, just optimizing one model beyond a point is difficult, especially if you're using closed source models. You can't do much there. All you can do probably do something on the data and the compute side. So those things are pretty complex, because the pipeline is running. We're processing millions of documents a year through these pipelines, or we even process audio files, we process all sorts of raw information. So yeah, so that those pipelines are fairly sophisticated, but I think the key for us is to make it as seamless for our internal and the external users, so that they don't feel big difference in their experience, but they get value.
Cool. No, that's Awesome. Thank you so much for sharing that. And how do you approach model interpretability and explainability in complex systems like that, especially when you're dealing with deep learning or ensemble methods that are like in black boxes that you can't see?
I mean, just mathematically, the more complex the model is, the less explainable it will be. So that's a fundamental constraint in the system, right? You can't have a very highly complex model which is highly explainable, right? I mean, don't want to get too much into the math of it, but broadly speaking, that's how this works, right? That so that's kind of an inherent constraint in the system. So you have to look at use cases. Interoperability is kind of, you don't want to get too white glove and have too many silos. So we try to build more industrial scale pipelines rather than build individual solutions. So platform, right? So that's how we think. But on the complexity side, models are going to get more complex. That's an inherent trade-off. Because if we want it to perform at higher levels of accuracy, it has to get more complex, right? There's no other way. At least with the current kind of attention-based architectures. Now, in some cases, if you are in a regulated business and it's some parts of and if you need very high explainability, then the trade-off is you will not be able to use very complex models. So the risk to reward ratio looks different in different use cases. In some cases, you could get highly complex where you don't need a lot of explainability. So that's the trade-off you make, right? There is no kind of silver bullet here.
Got it. No, that's a great answer as well. And collaboration between data scientists, engineers, and business teams is really crucial. How do
Yep.
you foster that alignment and ensure that AI projects deliver real value and impact for the organization?
I think this is a bit of a two-edged sword, right? Like data scientists, machine learning, these people generally they need some creative freedom as well for them to kind of satiate their own urges. But that at the same time, we don't want them everybody to go on their silo and build their own thing. So there's a balance to be struck here. In terms of value, we are obsessed about value at S&P. And one of the important things which to realize with our business is, unlike other businesses, data analytics, workflows, benchmarks are our products, right? It's not some byproduct in other, like data is not a byproduct, right? Data is our product, whether we give a rating or whether we do a benchmark or we generate an index or eventually everything runs on data. So
Yep.
that's kind of foundational to us. So the value proposition is very clear. All the data scientists in our teams, they are very, very clear on the ROI of the project. They understand the financial implications. But at the same time, we also give them some creative freedom to experiment and give them some runway. So it's a mix of both. In terms of collaboration, I think now just with the technology available, it just becomes easy to collaborate. We try to co-locate teams as far as possible, and also with the return to work, I think there are more kind of face-to-face collaborations. Uh, there's no kind of silver bullet here, but overall, I feel that we are fairly collaborative, and the platform mentality is very embedded in our teams. So when we build to scale, which inherently helps with the collaboration.
Cool. That's a great answer. Thank you. And for people that are, trying to get into AI or are trying to like reskill themselves, and I also get asked this a lot, and I sometimes don't know what to say. Like, what advice would you give to people, because things are moving so quickly? Like, what are the skills that you need to like be in AI right now?
Oh, that's a hard question.
I know, but what would you tell somebody if somebody
I
asked
think
you?
it all depends on what they want to do, right? If they want to be like a practitioner,
Yes, like practitioner.
yeah. See, I think fundamentally you need to understand the math behind it, right? If you really want to go deep, there is no shortcut there. Like you need to understand vector algebra, calculus, probability, you need to have a good hang of the math, right? Because if everybody has access to the same tools, how you optimize it becomes a function of your knowledge of what's happening behind the scenes, right? So I think a lot of people miss that part. They are very eager to jump into a project and start doing stuff. So that's something I would highly recommend for people who are wanting to go more deeper and want to build careers around the practitioner side, that you need to have a very good understanding of the basic math and statistics, which is, and I won't even say basic. I mean, you might have to go to some advanced levels. So that's something fundamental, right? If you're not interested in it, then you should reconsider your career in this space. So that's one. And it's not a bad thing, right? It is just you need some skills to kind of, if you really have to build a career. Secondly, you have to keep your options open, right? Like, not get too obsessed with things you build. I think engineers love to build stuff, but they don't like to kill stuff. So AI world, you'll have to be able to do both, because obsolescence will kick in very quickly in today's world. Like if we had this conversation a year back, I'm sure of the topics we would have been discussing would have been very different.
Yes, for sure.
So that's one. So math, have more an open mind, and you will get things wrong, right? So you will have to be ready for failures. There is no instant gratification in this space, right? You can't put something. I mean, people see all these videos and say, "Oh, if I build something, I'll build a product in 3 days." It doesn't work like that, right? You'll have to battle test it. So what looks nice in a test environment, in a real world environment, it is very, very different. All
Yeah,
right.
for sure.
And I think lastly, a lot of the engineering skills in software was based on coding skills. I think developers or machine learning or AI engineers will have to move from the concept of coding being their strength and still important, but also the ability to have more structured conversations or structured communication. Because they
Right.
need to be close to the business problem to be able to build the right solutions. So I think the best practitioners of the future would be who understand the math, who keep their options open, right, and are willing to kill stuff when it's needed, and also are very much embedded on the business side of things, right? You can't just do AI in a vacuum.
Right.
Yeah.
No, that's a good answer. And we started with this one, and I'm going to end it, but ask you, what are you excited to see in like the next 5 years versus like this year?
I mean, I'm very, very excited about quantum computing. I think it's
Well, yeah,
doesn't make
probably
as
more like 5 years, right? Not this year.
yeah, quantum computing, I think in 5 years, I mean, it's very, very difficult to predict the world in 5 years. I mean, anything I say, there's a 99% chance I'll be wrong. But
You could
quantum,
listen to this 5 years, go
yeah,
back and
yeah,
see what you said,
yeah, I could, if I was a betting person, I'll make a punt that I'll be wrong. But I think quantum computer has legs. Computing has legs. It'll go. I think it's still early days. Will I see a quantum computer in everybody's house in 5 years? Probably not. I don't know. But I think that's one big area I'm really excited about. Secondly, I think in the physical space, AI is still, there is a lot of inroads AI can make, right? When I talk physical space, I'm talking on work which involves movement of atoms, right? Not
Okay.
digital work,
Not
right?
like geospatial, right? You're not talking about.
No. I'm talking about like humanoids and things like that, right? I
Yeah.
think that area will be very, very interesting to see. I had the chance to look at some startups in Houston a couple of months back, So they're talking about humanoid welders and things like that. These are high risk jobs, right? Like,
Yeah.
so you'll see a lot of, I think that might happen much earlier than 5 years. I think that progress there has been very rapid. So that I see. And I'm also very excited about the potential of AI in education. I come from India, and one of the big problems in a country like India is the access to education is very asymmetrical,
Right.
right? So the government aided schools are not really good. So everybody cannot afford a private school. I think that's an area I feel AI could fill in some vacuum, because even in India, even if you go very deep into some hinterlands, everybody has internet connection now and it's high speed. So you
Mhm.
could, so I think those kind of like applications of AI, I think we are just scratching the surface, right? Like the kind of new products could be built, and I feel education is one area where it could be good for mankind as well, right? Because where a teacher cannot reach, an AI with good bandwidth can. So
Absolutely. I
yeah,
agree. Well, Dash, thank you so much for sharing your insights and experiences with us today. Your perspective on AI and machine learning and responsible innovation is incredibly valuable. And I know that our listeners will come away with a lot of actionable takeaways for applying these principles in their own work. And for our own audience, be sure to follow Dash's work, stay engaged with the latest AI trends, and come and see him speak at DSS ATX, which is coming up in a couple weeks in Austin on February 18th. And make sure to share this episode with your network. And we're really excited to continue exploring how data and AI are transforming industries, one innovation at a time. Thanks again for being here, Dash.
thank you for having me, Anna, and I'm looking forward to your event in Austin. Appreciate it. Thank you.
If you're enjoying listening to my conversation with Dush, you'll have a chance to see him speak at our upcoming event at DSS ATX on February 18th, taking place at Oracle's beautiful headquarters in Austin. Use code DSS Podcast ATX to get 25% off your registration.